Hello, my dear children. I hope all of you are fine and fit at your home. And as you know, we are doing now the chapter number 5, that is multiples and factors. So, in our last class, we have discussed about the test of divisibility by 6, 7, 8, 9, and 10. So, today we are going to discuss about the divisibility test of 11 in this class. So, let's see. So, students, test of divisibility by 11, that is, a number is divisible by 11 if the difference between the sum of digits at odd places and the sum of digits at even places is either 0 or a multiple of 11. Alright. So students, what does it mean? Do you know? Have you understood it? See, suppose we have taken an example, that is 4,97,365. So this is a large number. So without doing the actual division, how we can know it this number is divisible by 11 or no or not? Alright. So how we'll see it? We have to apply this test of divisibility rule. Okay, children. So we have to see the difference between the sum of digit at, but before this we have to know identify the digit at odd places and even places, not the number of odd number or even number. We have to look the odd places digit and the even places digit. All right, children. See here, this is a, as you can see here, if we have to write count the number, if we'll see ones, then tens, hundreds, thousand, 10,000, lakhs. So it is 1, 2, 3, 4, 5, 6. If there are how many digits? 6 digit is there. So which are the odd number and even number we have discussed in our last class. So odd, one is in odd places. So odd places digit we have to look. So odd places digit is what here? You can see, students, there is, what is there? Odd places is 1, then 3, then is next is 5. These 3 are the odd place, 1, 3 and 5. So odd places digits are what we have to look at now. So it is 5, then which one is coming? 5, then is third place, that means the third means 3, number of 3, it is also 3. As you are not writing that 3, because we have to look the odd places, which is also 3 and the digit also 3. So now next is, you can see here, fifth place, what is the digit is 9. So that's why we have written here 9. And fifth is it, as it is odd place, that's why we have to find out the sum. So 5 plus 3 plus 9 is 17. Okay, children. Now sum of its digit at even places we have to look. So even now, which are the coming even places? This is 2, 4 and 6. These are the even place. We have to look the place, not the digit even. Alright. So even places 2, 4 and 6. So 2 in second place, what is there? 6. Then which one is coming in fourth place? Is 7. Then in sixth place it is 4. So now after adding this, we have got here 7 digits. Now we have to find out their difference. So difference means these two we have to subtract. So 17 minus 17 will get here 0. Alright. As it is said, either 0 or you have to find out the multiple of 11. Since we have got here 0, that means this whole number will be divisible by 11. Clear, children? One next we'll do some problems, then it will be clear. So children, as in our exercise 5.2 we have done till that question number 5, and today we have to do that we are 6, as it is divisible by 11. Today we have discussed this divisible by 11. So let's see. I have written here the color the numbers which are divisible by 11 in orange. You have to do. So solution, what at first we will see is it the numbers are divisible or not, then we will put the color. Fine, children. So let's see. First one number is given, that is 121. Okay, all of you know that table of 11, so it's coming, it's a multiple of 11. Directly you can see it is divisible by 11, but it's a small number, that's why you can see easily. But if it is a larger number, how we'll see? You have to apply the rule. So but here also we will apply the rule. See here, sum of its digit at odd place. Odd place means it is ones place, then 1 2 3, these are the three places is there, as 3 digit is there. So ones place digit is what? 1, and next is odd, as it said odd place, so 1 1 it will come, and next third place is also 1, so 1 plus 1 2. Now sum of its digit at even places, you can see even places only the second position, you can see it is here only the 2, so that's why we have written here 2. Now their difference will be 2 minus 2, we have got here 0. So 121 is divisible by 11, as 0 is a multiple of 11, you can read. So clear students? Now that second one I have written here, so we have colored it. The given number is 4224. So sum of its digit at odd places, 4, we have to, odd places means ones place, second, third, fourth. If you will, by pencil if you will mark, you can find it visually, or if mind also you can do it. Okay, so it's from odd places means we have to see that ones, as 1 3 5, these are the odd numbers, so 1 it is 4, and then next is 2. At third place is also 2, so 4 plus 2 6. Okay, so sum of its digit at even places also, you can see the second places is 2, and the fourth place is also 4, so 2 plus 4 6, therefore the difference will be 6 minus 6 0. Hence this whole number will be divisible by 11. Same way we have done one more, you can see this 2 4 3 7, once, 2 second, then third, fourth. If you see, we have to find out the odd places digit sum, then what we'll do, what place is in the ones place, so 7 plus third is 4, so 7 plus 4, if you do, we have got 11. Now sum of even places is, even places you can see 2, second place is, as it is 3, and fourth place it is 2, so 3 plus 2 5, and the difference will be 11 minus 5, we have got here 6. So hence 6 is not the multiple of 11, therefore which is not a multiple of 11, so the whole number, that means 2437, is not divisible by 11. Fine children, I hope this is clear to you now. So rest of the sums can be done by you after solving, then you put it color. Children, fine. So our next topic is we have to know the prime numbers, what it means. So prime number means, students, any number greater than 1 which has only 2 factors, 1 and the number itself, is called the prime number. As we have learned in the property of factors, at least it should be 1, 2 factors should be have a number, alright, minimum. So if a number is having that factors only 2, 1 and the number itself, that number are called prime factor. Fine children, see here, like 2, how we can write? Only 2 into 1, others we cannot write, we cannot make it, right? So the factor of 2 is what? Factor of 2, you can see here, factor of 2 will be only 1 and 2. Okay, that means this is a prime number, rest we cannot divide it, so 2 is a prime number, alright. Same way you can, if we'll see it, like some example I'm giving more, like here you can see 2, it's already I have shown how it is, 2 3, then 5 7 11 13, etc. These are the prime number. As if you'll see 3 also, only 1 into 3 we can write, any, it's not coming in any other table, alright. So only these are the prime number, and more we can find, etc. That's why I have given. Fine children. So in same way we will see composite number, that means any number which has more than 2 factors is called that composite number. Like I have shown the 2, only we can write 1 into 2, but 4 if you will see, students, like 4 if you will have, see 4 means we can write 1 into 4 and 2 into 2. So what will be the factors of 4? Factors of 4 factors of 4, you will see 1, 2 and 4. 3 is coming, so which has more than 2 factors. So more than means there are coming 3 factors. So that's why it's also a composite number. Okay. Same way, if you see more example like 4, 6, then 8, 9, 10, then 12, etc. It's all are coming that composite number. At 6 also you can write 1 into 6, then 2 into 3. So there are 4 factors of 6. 8 also having so many factors, then 9 also having others 4 factors or 3 factors. Alright, so same way we will get more than 2 factors of this number. So this will be the composite number. Fine children. Next, one more thing is there that you should know, that is prime. That means what? 2 prime numbers with a composite numbers in between are called twin primes. That means what does it say? Means, students, have you understood? See, the prime numbers means, just now we have discussed that prime numbers means at least they have 2 factors more. So only 1 and the number itself. Say here just 1 and the number itself means the 2 I have shown. So same way 3 and 5 also, they are also prime. But in between, if you will see, in between 2 and 3, this is not the twin prime, as in between 2 and 3 both are prime number, 2 also and 3 also, but there is in between them no composite number is there. Alright, but if you see, so that's why it is not the twin prime. There should be any composite number. But 3 and 5, if you see, there is a 4 in between them. Yes or no, children? Is it? Yes. Next, if you see 5 and 7, there is also a composite number 6 in between them. That's why these are the example of twin primes. Alright children, like 5, 7, 11, 13, 17, 19, same way we can find out. Fine children, and we can define it any other way, that is prime numbers which differ by 2 are called twin primes. Defined by 2, that means if you will see here 5 minus 3, if you will get 2. So that means difference means difference will be 2. The twin prime numbers difference will be 2. So like 7 minus, if you will do here 7 minus 5, here also you will get 2. That's why it said differ by 2. Fine children, but if you will do here like 3 minus 2, you will get 1. So it is not the, that's why this is not called the twin prime. Although 2 and 3 are prime number, but these are not the pair of twin prime. But the like 3, 5, 7, these are the prime number. Fine children. So next, one more is, that is coprime. Okay children, see here, 2 numbers are said to be coprime if they have only 1 as their common factor. So only there, it's not the necessary condition of the number should be prime. It may be composite or the prime numbers also. Alright, but there they have only 1 as their common factor. Their common factor should be what? 1. As we have done, like in our last class, I have given this example 12 and 6. Their common factors are 2, 1, 2, 3, 6. These are the common factors. That's why this 12 and 6 and 12 is not coprime. Alright, but if you will do here, see here, if you do 3 and 4 are common primes, like 4 and 9 are common prime. But why? If you see 3 means we can write only 1 into 3. So therefore factors of 3 means factors of 3 will be only 1 and 3. Same way factors of 4 means we can write 1 into 4. So factors of 4 is equal to 1 into 4. Or you can write here 4 means we can write one more way, that 2 into 2 also we can write 4. So these are the factors. Here 4 factors and here also. But if you see the common between these 3 factors of 3 and factors of 4, only one is having common. Rest here is 3, but there is 4 and 2. That means these are not the common. of 3 and 4. So common means common factor is coming. Common factor is only 1, so that it's a coprime. So two numbers are said to be coprime if they have only 1 as their common factor. So they have only 3 and 4. 3 and 4 having only 1 as their common factor. Fine children. So I hope this is clear to you now.